Intermolecular forces. Atoms and molecules are very small. We can't actually see a substance unless it's made up of many particles. 1 ml of water at 4 degrees Celsius is equal to 1 gram of water. 1 gram of water has 3.34 times 10 to the 22nd molecules of water. What makes all of the water molecules stick together to make a large enough amount we can actually see? Intermolecular forces are the piece we need to add to the puzzle to explain the world around us. Without intermolecular forces, we wouldn't have tables, lakes, walls, or even our bodies. Intermolecular forces shape our world. We will explore the states of matter which result from those forces and then closely look at how molecular polarity results in one of them, hydrogen bonding. While there are many states of matter, the 3 common states that dominate our world are gases, liquids, and solids. The 2 fundamental differences between states of matter are the distance between particles and the particles' freedom to move. Liquids and solids are called condensed phases, since their particles are close together. In gases, the particles, which could be atoms or molecules, are far apart from one another and in constant motion. They're free to move anywhere in their container and, in fact, move everywhere in their container. The volume of the gas particles take up a small part of the volume of their container, so their container's almost empty. The motion of the particles is completely disorganized. As a result, this state of matter has the highest entropy. In liquids, the particles are in contact with one another and in constant motion as they slide by each other. There is little space between the particles. They are almost as tightly packed as a solid, but they can slide past each other. They don't have fixed locations. They can form to the bottom of their container, but don't fill their container since the particles must remain in contact with one another. They are far more ordered than gases, but less ordered than solids. So their state of entropy is between those two. In solids, the particles are in contact with one another and are locked in position. They're not free to move. There is little space between the particles. They are tightly packed. Their shape is independent of their container. They are the most ordered state of matter and have the lowest entropy. While there are many types of solids, the example shown here is the most ordered example, a crystal. Here is a little summary. Gas particles are far apart, free to move anywhere in their container, mostly empty space, and disordered. Liquid particles are close together, but they can move, but they stay in contact with each other. There's little space between particles, but they're more ordered than a gas. A crystalline solid, particles are close together, they have fixed positions, there's little space between the particles, and they're very ordered. Here is another summary of the states of matter. Gases match the shape of their entire container. They fill their container, they are compressible, they flow easily, and they diffuse very rapidly. Liquids match the shape of the container of the part that it occupies. They do not fill their entire container. They're virtually incompressible, they flow easily, and they diffuse slower than gas. Solids are not affected by their containers. They don't fill their containers. They're also virtually incompressible, they do not flow, and they diffuse slower than liquid or gas. The state of a substance at a particular temperature and pressure depends on 2 major factors: the strength of the intermolecular forces that hold molecules together, and the kinetic energy of the molecules. So here we have some molecules that are solid, we have liquid state of matter, and we have gas. Which molecules have the highest kinetic energy? Intramolecular forces are the strong covalent bonds that bind atoms together to form a molecule. Intermolecular forces are the forces between those molecules. Intermolecular forces are much weaker than intramolecular forces. For example, molecules of water break apart from one another when water boils, but the water molecules don't break apart into hydrogen and oxygen. Without intermolecular forces, all substances would behave like ideal gases. There would be no liquids or solids. Boiling represents a transition from a liquid to a gas. To make that transition, molecules in the liquid must break free of the intermolecular forces that bind them. The energy of the molecules increases with temperature. The boiling point refers to the temperature at which the molecule's energy overcomes the intermolecular forces binding them together. The higher the boiling point of a substance, the stronger the intermolecular forces. Water molecules overcome their intermolecular forces at 100 degrees Celsius.